Chapter 8, Section 3, negative exponents. We'll also talk about exponents of 0 in this section as well. That's what we're going to talk about first, is the 0 exponent property. This one is really easy. Any non-zero number raised to the 0 power is equal to 1. So if you have something raised to the 0 power, it is
1.
1.
It's just 1.
It's not 0, it's 1. Okay? That's it for the 0 exponent. You okay with that? So, examples. If I've got 30 to the 0 power, it's 1.
Wow.
Even if I have a quotient, the whole thing raised to the 0 power, it's just 1. Fraction raised to the 0 power, it's just 1. Even if I get a really big number, 5,272,894 raised to the 0 power, it's 1. Okay? We okay with that?
Yes, sir.
That's probably the easiest one. Right? Huh? If the thing is raised to the 0 power, it is 1. Yes. Any questions about this property?
No, sir.
Give some examples.
Ready for some examples?
Yeah.
Can I move on?
Yes, sir.
Simplify each expression. Assume that no denominator equals 0.
Easy.
Letter A. Negative 8m squared n p to the 8th over 9k squared m into the 4th. That whole quotient is raised to the 0 power. Any ideas?
Oh, I know.
Yep.
1.
Yep.
Yay.
That whole thing is raised to the 0 power, so my answer is 1. We okay with that?
No. Yes.
Easy peasy?
Hold on.
Yeah, you don't have to do anything with it. Yeah.
Oh, wait. Okay, so
If the whole
the
thing
whole thing is being...
is raised to the 0 power,
Ah.
your answer is 1.
That's what would make it equal 1.
Letter B. Is the whole thing raised to the 0 power?
No.
No. So the whole thing's probably not 1. So let's figure this one out.
I know.
You could simplify b to the 0 first off. B to the 0 is what?
1.
So that'd be a to the 4th times 1 up top. Right? Everyone agree with that? B to the 0 turned to 1. Anything times 1 is just itself, right? So this is just a to the 4th over a squared. Is that simplified as far as it'll go?
Yeah.
That was
No,
because
no.
there's another A.
So we're dividing here. It's a fraction. Are we dividing with the same base?
Yeah.
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 What can I do if I'm dividing things with the same base with the exponents?
Subtract it.
Subtract them, right? Top minus bottom. 4 minus 2. 2. So this becomes a squared. You okay with example 1 here? A and B.
Yeah.
Any questions? Easy.
Ooh.
Not incredibly difficult or anything.
No. That was really hard.
Can I move on?
Yeah.
Yes, sir.
Negative exponents, that's what the rest of the notes are about. Any non-zero real number can be raised to a negative power. That power is called a negative exponent. So here's the formal definition or whatever, how we handle negative exponents. For any non-zero number a and any integer n, a to the negative n power is the reciprocal of a to the n. Also, the reciprocal of a to the negative n is a to the n. For negative exponents, the easiest way that I can explain it to people, so first off, we don't want negative exponents in our answer. We want all positive exponents. So we got to get rid of the negative exponents somehow. The easiest way I can explain it, if your negative exponent starts off in the numerator, to make it positive, I need to move it to the denominator. If your negative exponent starts off in the denominator, to make it positive, I move it to the numerator. So essentially, you're just changing its position within the fraction. Just the thing with the negative exponent. Okay? Everyone okay with that? So, examples here. I've got 3 to the negative 5th. Is this written as a fraction right now?
No.
No. How can I make that a fraction?
Put 1 over it.
Put it over 1. Okay?
Yeah.
To make anything a fraction that's not already a fraction, I put it over 1. Correct? Okay. What's 1's exponent here? 1. I'm only moving the thing with the negative exponent. So just 3 to the negative 5th, it's in the numerator, needs to move to the denominator. Is this 1 to the first power moving at all?
No.
Does it have a negative exponent? No. It is staying where it's at. So down here, I would get 1 over 3 to the 5th. That 1 is still there being multiplied by 3 to the 5th. But anything times 1 is itself. That's why that 1, you don't see that 1 there. Up here, there was technically a 1 up here as well. That 1 also stayed. A lot of people think you flip the fraction. You're not really flipping the fraction. You're just moving the thing with the negative exponent. Okay? So, I get 1 over 3 to the 5th. 3 to the 5th is 243, so I get 1 over 243 as my simplest form answer. We okay with that? Okay. Another example. We get a negative exponent in the denominator now. To make it positive, I need to move it to the up to the
Top.
what's the top of a fraction called?
The numerator.
Numerator. Okay. So I move it up to the numerator. That was the only thing down here. So what's understood to be down here now is 1. Anything over 1, we don't need to write that 1 in the denominator. Okay? So I get m squared. Questions about that? To make a negative exponent positive, change its position within the fraction. Just the negative thing with the negative exponent. Okay? We okay with that? Okay. I would definitely write these things at the bottom down as well. These are important to know, especially if you're taking a quiz or a test over this. An expression is considered simplified, so completely simplified in its most simplest form, when it contains only positive exponents. You don't want any negatives. Each base appears exactly once. If a base is appearing more than once, I could probably use my product of powers property or my quotient of powers property to simplify it further. So each base only appears exactly once. There are no powers of powers. So there's nothing in parentheses raised to another power. And all fractions are in simplest form. I can reduce, or all my fractions are reduced as far as they'll go. I would definitely know those 4 things. Any questions about this slide before we look at some examples? Okay, I'll give you a little bit more time to write down. Okay, let's go ahead and move on. Example 2, simplify a to the 3rd, b to the negative 4th, all over c to the negative 2nd. Assume that the denominator does not equal 0. So, first off, am I multiplying or dividing anything with the same bases or anything like that? Nope. Each thing has its own base. Do I have any powers to powers? No. I do have negative exponents though, correct?
Yes.
How do I handle negative exponents?
Divide.
Not divide.
Multiply.
Nope, I don't have to multiply anything either. In order to make negative exponents positive, I change the things with negative exponents positions in the fraction. If I have a negative exponent in the numerator, it has to move to the denominator. If I have a negative exponent in the denominator, it needs to move to the numerator. So, what things are moving here? What? C to the negative 2nd. It's in the denominator, so it's moving to the numerator. Is that the only thing with the negative exponent? No. B to the negative 4th is in the numerator, so it's moving to the denominator. Is a to the 3rd moving? No. It has a positive exponent, so it stays where it's at. We said c to the negative second moves up and its exponent becomes positive. B to the negative fourth moves down and the 4 becomes positive. I can't do any more simplifying. Here's my answer. Only the things with the negative exponents move within the fraction. Okay?
Wow. That's tricky.
Does this contain only positive exponents?
Yeah.
Well, right here.
Yes.
Yeah.
Oh,
Yeah. Does each base appear exactly once?
yeah. Yeah.
Are there any other A's?
No.
Nope. Are there any other C's?
No.
Are there any other B's?
No.
Nope. So each one appears exactly once. Are there any powers of powers?
No.
No.
No. I have nothing. I don't have a power inside parentheses raised to another exponent. Is my fraction in simplest form?
Yeah.
Yeah. There's understood to be a 1 here and a 1 here. 1 over 1 can't simplify any further, so it is in simplest form. So, since it meets all 4 of these conditions, my answer is considered simplified, so that's where I stop. We okay with that? Questions on example 2 here? Can I move on? Example 3. Simplify. 3g to the negative third h squared over negative 36g to the third hj to the negative fourth. Assume that the denominator does not equal 0.
Wow.
There's a few ways I could approach this. Any ideas on what you guys would want to do first here?
Yeah.
Bring the HJ negative 4 up
To the numerator?
the numerator, yes.
Would I bring h and j to the numerator?
No.
No, I think it's
Yeah.
Just j. What's h's current exponent here in the denominator?
Uno.
1.
1.
Is that a negative exponent? No. So just j to the negative fourth would move to the numerator. Is that my only negative exponent?
No.
No.
G.
G.
G to the negative third would move to the
Denominator.
denominator. You okay with what we've done? The very first thing we did here was take care of the negative exponents. Everything with a negative exponent changed its position within the fraction. Everything else that had a positive exponent stayed where it was. Questions there?
No, sorry.
Okay, what could you guys do next?
Uh,
Or is this in simplest form?
no.
No, it's not.
You gotta combine both, or, yeah, right? Combine the cheating one.
Yeah, down in the denominator, this is multiplication, right? In the denominator. It's negative 36 times g to the third times g to the third times h, correct? We're multiplying things with the same base. So what can I do with their exponents? Add them. Three plus 3 gives me 6. Okay with that step? Is that in simplest form?
No.
No. The h's. I've got an h in the numerator and an h in the denominator. AKA we're dividing things with the same base, right? If I'm dividing things with the same base, what can I do with their exponents? Subtract. So 2 minus 1 would give me 1. H to the first. Are we okay with that? Is that in simplest form? Let's check. Does this contain only positive exponents?
Yes.
Yes, it does. Check. Does each base appear exactly once?
Yes.
Yeah, I only got one H, one J, one G, one 3, one negative 36. Each base appears exactly once. Check. Are there any powers of powers? Do I have any powers in an exponent raised to another exponent? Nope. Check. Are all fractions in simplest form? No. I've got 3 in the numerator and negative 36 in the denominator. What are 3 and negative 36 both divisible by?
3.
3.
Wow.
So this is not in simplest form yet. I've got to simplify that 3 over negative 36. 3 divided by 3 gives me 1 hj to the 4th. Negative 36 divided by 3. Negative 12 d to the 6th. Is that fraction now in simplest form?
Yes.
Yes, it is. We okay with that?
Yes.
So, it's just you kind of doing whatever steps you want to do first with these exponents. If I wanted to, I could have subtracted exponents with g and exponents with h right off the bat. If I wanted to do that step first. I could have simplified my fraction first if I wanted to. The steps really don't matter when you have a bunch of the exponent properties within a problem. Okay? As long as you get them all covered and your new fraction meets all 4 of these conditions, then you're good. We okay with that? Questions on example 3?
No. That's true.
There's your assignment. Are there any questions about any of the notes before I end the recording?